Just find the Fourier transform of fx equal to e to the power minus ax for x greater than 0 and 0 for x less than 0. Observe that as x tends to 0, e to the power minus ax will tend to 1, and as x tends to 0 from left hand side for negative value of x, fx is 0. So this function is discontinuous, but we can find a Fourier transform for this function. Fourier transform of a function fx is given by fs of x equal to minus infinity to infinity fx into e to the power minus sx x dx. Observe that Fourier transform will change from x to s. If you look at this integral, after integrating, ultimately you have to put the upper limit of value of x and lower limit of value of x. When you do that, x will vanish. So this will be a function of s only. So that is what Fourier transform gives us. Now this integral can be written as minus infinity to 0, because function is defined to be 0 from minus infinity to 0 and then 0 to infinity. The function is defined to be e to the power minus ax for fx lying between 0 and infinity. Once again, minus infinity to infinity fx into e to the power minus isx dx can be written as minus infinity to 0, 0 dx, because for negative value of x, fx equal to 0, and then 0 to infinity for positive value of fx, fx equal to e to the power minus ax. Now integral of 0 is 0, so we don't have to write it. Now if the base are same, power can be added, so we add the power and we take the x common. Once you take x common, you have minus a and minus is times x. Now you know that integral of e to the power ax is e to the power ax by a. So let's put the value. As x tends to infinity, e to the power minus infinity is 0, so we have 0 here, and lower limit as x tends to 0, e to the power 0 is 1. So you have minus minus gets cancelled and you are left out with 1 by a plus is. So this transform a function as given in the question to a simple expression a plus is.